Hi guys, welcome to another video. We are talking today about circles once again, but we're going to take this idea of sketching circles one step further and look at how we can apply this idea of intersection between multiple graphs. So we're looking here at intersecting circles and lines. Now to do this, we're going to be revisiting something we talked about extensively earlier in this series, which was the idea of simultaneous equations and solving these ones here. Now, we're just working through one question here, but this is going to require us to solve, to sketch this as well as solve for the these points of intersection. Now, let me actually change this value. We are trying to find the coordinates of the points where x squared plus y squared equals 9 intersects y equals 2x. Now, first of all, we want to just identify what the graphs we're looking at here. So this is a circle. We looked at this in the previous video, and we have a line here as well. So we're going to be working with these two particular graphs. Now, if we even think about just doing a rough sketch, we don't even need to draw something perfect, but we can sort of understand what this looks like, and then it'll already give us an idea of the type of solutions we have. Now, if we have this circle, x squared plus y squared equals 9, remember our circle formula is given by x squared plus y squared equals radius squared. Now you may notice that 9 here is a square number. We can get it from squaring 3. So here we can rewrite my equation up here as x squared plus y squared equals to 3 squared, where the 3 here is my radius. So this is a circle whose center is the origin, because remember, there's no transformations being happen. There's no shifting of x or y. So this is a circle whose center is at the point 0, 0. Now, if we draw this particular thing here, we get a circle, and it has a radius. So its length kind of out everywhere from the center to the boundary of the circle is going to be a length of 3. That's given to me in the formula. So I have 3 here, positive 3. Now 3 units to the left of 0 on the x-axis is going to give you minus 3. In the same way, 3 units underneath 0 in the negative y-axis is going to give me negative 3. And I have some line of y equals 2x. So just drawing a random line in, y equals 2x, it's going to pass through the center, and it's going to look something like this. So we can already tell just by considering what this looks like, what my two graphs look like, I'm already identifying, okay, I'm probably going to have two solutions here. So if I don't get two solutions, it tells me, wait a minute, something may have gone wrong here. But let's leave this as it is, and we're going to work through finding what these exact points are. So to find intersection points, remember we are solving pairs of simultaneous equations. So we have x squared plus y squared equals to 9 as my first one. We're calling that equation 1. And y equals 2x is my equation 2. Now remember, at these points of intersection, we've talked about this a lot, but just to reiterate, the x values are identical and the y values are identical. They are the same here. So at this point of intersection, my y in equation 2 is exactly the same as y in equation 1. So therefore, I can substitute this thing here, because y is equal to 2x, I can substitute 2x up here. And that's going to give me an equation to solve with just with just x values here. So what I'm going to do is I'm going to sub y equals 2x into equation 1. So that's going to give me x squared plus, and I have here 2x all squared equals to 9. And now I just want to square this particular thing here and see what I end up getting. Now 2x squared is the same as 2x times 2x. So doing that, that's going to give me 4x squared. Or we can think of this in terms of indices, where when we take the power of something, of a product, it's going to be applied to both of these elements here. So I'm going to square 2, I'm going to square x as well. Squaring 2 gives me 4, squaring x gives me x squared. So it works in both kind of ways here. Now we want to solve this particular equation. And I can see here that I have an x squared here and an x squared here. So these guys here, now remember, if I have just x squared on its own, it's implied that this is one lot of x squared. But these are like terms, because they are both x squared. Now, algebra tells us when I have like terms, I can add or subtract the coefficients, the numbers in front. So what I'm going to do, this is hopefully a revision for a lot of you. 1 lot of x squared plus 4 lot of x squared gives me 5 lots of x squared, and that equals to 9. And now I can just solve this remaining equation. I'm trying to get to x on its own. And here 5 is multiplying by x squared. So I'm going to divide both sides by 5. That's going to undo this multiplication of 5 here. I wind up with x squared equals to 9 over 5. And now I just want to take the square root of both sides. Taking the square root of the left-hand side will give me x on its own. And what I do to one side, I do to the other as well. So x here gives me plus or minus root 9 over 5. Or root 9 over root 5. But remember, the square root of 9 is a perfect square. So taking the square root of 9 gives me 3, and the square root of 5 is a surd, so I can't simplify this anymore. So in other words, now I have found the x values, which are solutions to this particular equation. So as we confirmed through our image, here I have a value of x being plus or minus 3 over root 5. So that means I have two particular solutions, two intersection points. And if we look down here, when I drew it originally, I kind of have probably, it looks like it, two intersection points. But we want to find exactly what those are. So once I have this value of x, well, these two values of x, I need to find the value of y. So I'm going to substitute my value of x into either equation 1 or equation 2 to get a value for y. Now remember, we want to always go with the path of least resistance, the simpler of the two equations, because it makes our lives easier. So I'm going to substitute this into equation 2 because it's just going to be way easier to work with. So we're going to substitute x equals plus or minus 3 over root 5 into equation 2. So I'm going to get two solutions, two y coordinates. One of those is going to be when I do 2 times, now substituting in 3 over root 5 in place of x, I get 3 over root 5, positive 3 over root 5. And my second one is going to be y equals when I substitute in the negative value here. My second solution here. And that gives me 2 times minus 3 on root 5. So these are my 2 solutions for y. Now, quickly getting this one, 2 times 3 over root 5 gives me 6 over root 5. And this one gives me 2 times negative 3 over root 5 gives me negative 6 over root 5. So, therefore, I can say, therefore, points of intersection, the coordinates of my points of intersection are, one of those is positive root 3 over 5 and then 6 over root 5. So I have 3 over root 5, 6 over root 5. That's my first one here. And my second is going to be negative 3 over root 5 and negative 6 over root 5. Now, just from drawing my rough sketch, I can kind of already see that this is what I sort of expected anyway. Now, if I draw these in, I'm just doing a rough sketch here. I'm going to get something that looks like this, where I have my line of y equals 2x. The equation of my circle is x squared plus y squared equals 9. And my 2 intersection points, one of those, let's do a different color. One of those is this point here, which is going to be my x value is positive, my y value is positive. So I have this particular point here. So this is the point 3 over root 5, 6 over root 5. And I have this point down here where my x is negative, my y is negative 2. So I have this kind of point here. So even through my rough sketches, I can still get a feel for the answers that I'm expecting. It takes you a couple of minutes at the start, but it may save you a lot of mistakes and give you a chance to sense check your answers as well. But shading in this point here, that's going to be negative 3 over root 5 and negative 6 over root 5. So those two are my points of intersection. When my circle here intersects with my line. These two are going to meet, they're going to cross at 2 different points, and we find these by doing what we've been doing this whole time, which is setting up a pair of simultaneous equations, some non-linear ones. One of them is a line, y equals 2x, one of them is non-linear, it's a circle. Setting these up and solving them via substitution like we did back when we looked at parabolas and things like that. But that brings us to the end of this video. Thank you so much for watching, and I will see you next time.